Welcome to a science policy webinar from the 0PM project. So for those of you who don't know 0PM, this is a Horizon 2020 research and innovation project where we're looking at 3 interlinking strategies: prevention, prioritization and removal, to protect the environment and human health from persistent and mobile substances. And for those of you who don't know me, I'm Sarah Hale and I work at the German Water Centre. And today it's my great pleasure to be able to introduce our webinar. So we have one speaker today with us, Magnus Løfstedt, and he is an expert in chemicals, human health and the environment, and he works at the moment for the European Environment Agency. He's previously worked at the Danish Environmental Protection Agency as a regulatory toxicologist with industrial chemicals and chemicals in consumer products. And Magnus has a vast experience at the science policy interface. So that's actually the topic of today's webinar. We're going to be talking about how science is translated into policy, taking an example which I think everybody is familiar with, PFAS. So we're looking at what's happened prior to now, and we're also going to be discussing how scientists can contribute to the discussion that we're having up at the policy level. So I will invite everybody to put their questions to Magnus in the Q&A box. If we don't get around to answering all of them, then we'll follow up afterwards. And we're recording the webinar, so we'll pop it onto the 0PM YouTube channel. So what I am going to say now is, Magnus, if you would like to share your screen, then you'll be all set to go.
Thank you, Sarah, and good afternoon, everyone. Welcome to this webinar. So I met with Hans-Peter Arp last year during a PFAS meeting in Copenhagen, and during a coffee break, we had a discussion on the science to policy interface and how scientists can improve the uptake of their research into policy or into regulatory processes. And he asked me if I wanted to come and give a webinar presentation, which I, of course, said yes to, because I think this is a very important topic. It's also something that's very close to my heart. I've been working in the science to policy interface for my entire career. And then I thought, why not use PFAS as a case study and see what can we actually learn from 25 years of work on PFAS. It's also something that, of course, is of high relevance to the 0PM community. And then it's something that where I have quite a lot of personal experience. And it's quite funny because I started my professional career after graduating university in 2006. My first job was in the chemicals unit of the Danish EPA. And I started in the month of November. 1 month later, in December, a ban on PFAS was adopted in the EU. And I remember, because we had a small celebration in the office, Denmark was one of the countries pushing for a ban back then. And I thought, well, that's the end of PFAS. Now we can continue working with other substances. But I think that was probably a bit naive of me because I've been spending quite a lot of time on PFAS. And of course, meanwhile, it has been expanded to the whole group of PFAS. But it really exploded maybe 10, 12 years later when we had a PFAS scandal in Denmark, like there has been in many other countries across the EU. And my office was asked to look back and clarify what we had known and how we had acted on that knowledge all the way back to the year 2000. This is why the title of the presentation is quite specific, 25 years of work. And I thought some of this analysis that we did at that time could be relevant, and to look at the science to policy interactions that we've had during the years and how it informed and had an importance for the policy development. We were also, my office back then, involved in the PFAS restriction proposal under REACH as one of the competent authorities who were behind that restriction. So I've been working quite closely with PFAS. Now, of course, I'm not working in the Danish EPA anymore. For the last couple of years, I've been a civil servant in the EU, now working for the European Environment Agency. But here we are also working with PFAS. So I'll also use some of the stuff that we are doing here as examples. And I will actually start by giving a short introduction to what we are doing at the EEA. After that, I will talk about science to policy interactions in more general. Then we will go through the PFAS case study, and then finally, hopefully, I can come up with some conclusions and recommendations based on that. So first of all, the EEA, who are we? We are a European agency, a little more than 30 years old, and we have around 300 employees, which position us quite in the middle between the European agencies in terms of how many people are working here. Perhaps our most important task is to receive data from member countries, data on different issues relating to the environment. We collect these data from the cooperation countries, which is a broader number of countries than just the EU countries. We also have countries from the Balkans, Turkey, and so on included in the EEA countries. And then we also have more than 400 associated partner institutions, including scientific research institutions. We have something called ETC, European Topic Centers, that perform different types of analysis for us based on those data that we receive. And the main activities, well, we are not a regulatory agency. We are a knowledge agency, a networking agency, and an advisory agency. So we, of course, receive all this data. We need to have good infrastructure for that. And then we analyze the data, and we use that to come up and produce policy relevant analysis on both environment and climate topics. And this can then be used, picked up by decision makers, for example, people in Brussels, the Commission, Parliament, Council, or also the national ministries. And we try as best as we can to support those processes with knowledge. And you can also see on the right side of the screen here that we have quite a lot of different topics that we cover. So biodiversity, climate change, human health and the environment, circular economy, and sustainability. And actually, chemicals is a very minor part of what we are doing. We are very small. We have other agencies in the EU who are more or less dedicated to chemicals, like, for example, ECHA in Helsinki or EFSA in Italy. We have probably around 5 people working on chemicals, so we are really the smaller sibling here with regards to that. And as I said, we are not a typical regulatory agency. That means we do not perform risk assessments of chemicals. We don't regulate the chemicals. We receive the data, as I said, for chemicals, especially in relation to monitoring data, what is found in the environment. It's also what you find in humans, human biomonitoring, and it's industrial emissions from the big industrial sites and factories in Europe. And then we use that to perform systemic and cross-cutting assessments. So our strength, of course, lies in that we have all the different resources also on biodiversity, climate change, and so on in-house. So we can make these more cross-cutting assessments where our sister agencies, ECHA and EFSA, have more limited mandates and are perhaps focusing more narrowly on risk assessment for exposure via food or in other specific scenarios. So I think all of you know that we have quite an extensive regulatory landscape when it comes to chemicals in the EU, and these are not even all of them. Altogether, there are more than 40 different legislations in place to safeguard human health and the environment. And they are all interconnected in one way or the other. So this is, of course, quite a big challenge when you want to understand how can your scientific research fit into and contribute into the development of these frameworks. You could also see it in another way conceptually here. What you see is on the top, you have a number of regulations that are producing knowledge. So these regulations, they contain requirements for industry to perform studies or other types of information and to send those informations to the authorities. So REACH industrial chemicals, there you have data information requirements specifying which types of tests you need to perform for your chemicals. Biocidal products and plant protection products, it's quite similar. And this data can then be used for various processes. But the first step after you have this data is to do the hazard assessment, which is done via the classification and labeling CLP regulation, which is a general overarching sort of regulation that applies to all the different chemicals. And then based on the hazard assessment under the CLP, that can then inform you on how the substances can be used. It can also open up for other types of information requirements. And there you have the sector-specific also legislations in the bottom. So that could, for example, be chemicals in toys, in cosmetics. And again, here you have pesticide, biocides, and REACH, because those legislation both contains the more overarching data producing requirements, but also the regulation, the downstream regulation of the chemicals. Where you find the EA is on the bottom right side here. It's the environmental protection and monitoring legislation, and especially the monitoring. So you could also say that in the top of this picture here, you do include exposure modeling in your dossiers that you produce. But what we do from the EA side is that we have the actual measurements in the environment, in humans, air, water, surface water, drinking water, and so on. And that can also be used as a reality check to see how well is actually your exposure modeling that was performed before you put substances on the market. So in a way, you could say all these different legislations, they complement each other and they are interconnected. Now, diving into policy development, I think it's important that we try to discriminate between the policy development processes, which is when you develop new regulations or directives, or when you revise existing legislation. The other term I'm going to use is the regulatory processes. That is within a specific directive or regulation when you evaluate a chemical and then regulate it based on that evaluation. So the first one here is a policy development, which usually start with the identification of an issue. So you see there is a problem. As a society, we need to react. And this is, of course, general in all the different areas. But when it comes to chemicals, usually the researchers plays quite a huge role here, because it's very often research that points towards the problems and they points towards a need for action. And of course, the agency also plays a role here. Agencies also produce knowledge themselves through various projects, but they also have an intermediate responsibility that they need to pick up the research and then communicate it to the decision makers and policy developers further along in the process. Here, the agency role is limited in a way that you need to explain the problem. Sometimes you can come up also with solutions on how to deal with the project, but it's important not to preempt the way you discuss these solutions, because really it is the responsibility of the policy developers. In EU, it's the Commission who develop new legislation, and they are the ones who also look into the most suitable solutions. Typically, there will be different solutions you can use to address the same problem, and they will all have advantages and disadvantages. And here the Commission typically can look broader than just on the initially identified issues. For example, some toxic effects. They might also look into socioeconomic impacts. They might look into competitiveness, economy, and all kinds of other aspects that could be important or could be affected by those solutions that you want to create. Once the Commission have developed a draft legislation, then it goes to decision making. This is often referred to as a trialogue process, where the Council, the Parliament, and the Commission then negotiate the final legislation. Here, the Council represents the member state authorities, the Parliament represents the people of Europe, and the Commission then takes care or safeguard the interest of the EU. So to make sure that everything is being taken into account in this process. And then finally, when it has been decided, it goes back to the agencies, who are then often responsible for implementing the new rules. And this could be, for example, by publishing guidance document on how to understand the legal provisions and what to do more specifically than what has been written in the law. So this is a process, and during this process, of course, there are multiple opportunities, there are consultations and so on, where also stakeholders' viewpoints are being taken into consideration. If we then look, instead of the policy development, on the regulation part, this is what happens within a regulation. Let's say it could be REACH, it could be pesticides, could be biocides, but this is when you regulate a specific chemical or a group of chemicals within that specific regulation. And here again, of course, all good regulation starts with good knowledge. And this is often generated by the scientific community, or it could be generated by industry, where they have provisions telling them which data to use. And all this data is then going into the assessment from the agencies. And I think this is probably an area where sometimes there could be misunderstandings and so on, because even though you try to have an open process here, it's not everything that can be published. Some of the data might be confidential of what the agencies are working with. And I think sometimes the research side cannot see everything that has been taken into account, although as much as possible is being published afterwards. Again, here the agency level, they do the hazard and risk assessment, and then the risk reduction measures is usually decided again at the policy level. So it goes to the commission. So you often see opinions coming from the agencies, and then you see the decisions coming from the policy level. There are some exceptions between the different regulations. I'll not go into that because that would take too much time. That was a very sort of broad introduction to some of the processes that are involved here. So let's have a look at PFAS and what actually happened here in those 25 years. I'll actually go even a step further back, because to understand the present, we need to also understand the past. And we had in the beginning of, actually it was in the end of the 70s, at that time there was a growing awareness that we need to do something about industrial chemicals. Even before that, there had been work on pesticides, but industrial chemicals was sort of assumed to be safe. But then there was, of course, all the exceptions that we know, PCBs, asbestos, and so on and so on. So something needed to be done. However, at this time, the world economy was not doing very well. We had a very high inflation, and there was a bit of skepticism of putting too high pressure on the European companies to invest a lot of money in producing data. So what they did back then was that they said, okay, let's assume that all the chemicals we have on the market now is safe, and then make a lot of requirements for new substances that are being developed. This resulted in approximately 100,000 substances being registered as existing substances. Even substances that were not produced or on the market were put on this list, because some companies said we have this chemical, just to be sure, because then they would avoid submitting any data down the line. And in the following around 20 years, only 5,000 new substances came on the market. So it turned out that perhaps these amendments to the directive were not adequately serving its purpose. So later on, it was decided, let's do something about the existing substances. And then the existing substances regulation came along, and here the member states were required to or not required, but they performed risk assessments of prioritized substances. So in this pool of 100,000 substances, they assessed around 140 substances altogether. It took a very long time. It was very ineffective. This was why REACH was eventually invented, to replace the system. The interesting thing here is that PFAS went completely under the radar in this process. PFAS had been on the market since the 40s. It was a high production volume chemical. Everybody knew it was being used in many different places, but nobody picked it up for assessment. This, of course, relates to the regulatory agencies. It also relates to the researchers. Nobody looked into this. Do we have a problem with PFAS? We don't know. And it's perhaps one of the interesting things to discuss. Why did it take so long for us to discover the problems with PFAS? So this is actually the game changer, the smoking gun, if you may. This was an email that was sent from the US authorities to the OECD contact points. It was sent the 3rd of May in the year 2000. Hence, we almost have a 25th anniversary for the discovery of the harmful effects of PFAS in Europe. And it was quite unusual to actually receive such an email from our US colleagues. If you've seen the movie Dark Waters, then you probably know the history leading up to this. The discovery of the whole issue in the US. And this was how they actually then informed their European counterparts about their findings. And you might see here that already here they point towards effects in a 2-generation reproductive toxicity study in rats, where very unusual findings in the 2nd generation. They point towards that the substance appears to combine persistence, bioaccumulation, and toxicity to an extraordinary degree, and also that there is an indication at least of an unacceptable margin of exposure for workers and possible the general population. So this indeed was a clear red flag, and then what happened next is that we received this email the 3rd of May. Already later the same month, there was an OECD meeting, and it was agreed that the OECD should continue the work here. And a number of countries volunteered to lead the work, the US, Canada, and the UK. And they started a hazard assessment that was published a few years later. And then later also the UK continued then performing risk evaluation at the UK, but also at more European level, you could say. And in 2005, the Commission then published this intention to ban PFAS, and it was already then adopted in the end of 2006. Actually, you might think that 6 years is a very slow process, but I think it's actually quite fast. There was a lot of work to be done, a lot of exposure assessment, which you can't see from these titles here, but monitoring processes, where do we find the substance, and so on and so on. A huge amount of work. And also the first TVI was established in 2006 by the UK, and in 2009 it was listed on the Stockholm Convention for a global ban. Again, after that, we all realized that we had all the other PFAS compounds. But what's interesting also to look at is actually the toxicological threshold values. So the TDI, the tolerable daily intake, what happened to that during the years? And here you, of course, have to see that the scale here is logarithmic. So it's actually a very, very large difference between the first reference values and the last ones that we had 15 years later. If you look at these ones, they were actually derived based on information submitted by industry. Rodent studies, liver effects were used as point of departure. And they, even though, of course, you see they get a bit lower over time, it's still in this not too much of a difference. But actually, if you look at the last one derived by the Danish EPA in 2015, it was derived by the office I was working in back then. And I remember there were huge discussions with the scientific community when we had the public consultation of this. It was used to derive a drinking water limit for drinking water in Denmark. And already back then, a lot of researchers said this is way too high. We have information that it should be much lower. However, there were also some disagreement between different researchers back then if you could actually use this new information. But that's what actually happened when EFSA made the latest assessments. They went away from using the animal studies and instead using the epidemiological studies on vaccine response in children. And here you saw a massive decline in the safe threshold levels. It also means actually that going from the first set of reference values, you would assume that we don't have a general problem. We might have a problem in PFAS hotspots close to factories and so on. Whereas with the newest reference values, it seems to be a much more widespread problem also for the general population by ingestion of food items and drinking water in perhaps more uncontaminated regions. So that's, I think, an interesting development, and also a development where you could say at least the last point here was really driven by scientific research and the epidemiological studies. And then, of course, I mentioned PFAS is only the top of the iceberg, and now it's really the big question. We know a lot about PFAS, PFOA, and a few others, but what about all the rest? And how are we using the research funding that we have? How many studies are being performed on the well-known PFAS compounds versus the more unknown ones? I think that's also an interesting question. How many regulatory activities are performed on the ones we know versus the ones we don't know? This is something, at least from my side, where I think it's important to also look at perhaps at the more unknown unknowns in this regard, because we're working with this huge group of substances. This is, of course, also what's being addressed now by the universal PFAS restriction, saying we cannot address this huge group of substances one by one. We need to do something where we look across the different compounds in this huge and also heterogenic group of substances. Now, from the EEA side, of course, we have been very interested in what do we actually see in people. And here you see actually data collected under the Human Biomonitoring Initiative in Europe, measurements from a number of different countries in the EU. And you see how many people have concentrations in their blood that are higher than the latest reference value or TDI value derived by EFSA, which has then been recalculated to an internal level. And here again, this also, of course, points in the direction that exposure to the general population is too high. You see between 7, 8 and up to 20, almost 24% of the European population is exposed to too high concentrations of 4 different PFAS compounds. We have also observed that there has been a decreasing trend for PFAS and PFOA, which of course points in the direction that we are improving and that regulation do actually work. So what is the EU doing now? You probably heard about the Chemical Strategy for Sustainability, which was published by the last Commission, where PFAS was quite an issue, and there was here a political ambition to ban all the PFAS as a group in firefighting foams, and also to do a lot of other stuff. And this has actually initiated a lot of different activities at EU level, and I'll go quite quickly through them, but of course, a lot of research funding. I think is the Zero PM, also a lot of work in PARC and in other EU-funded research programs. You see PFAS being included. We have the development of safe and sustainable by design, which is also a way to try to look at perhaps chemicals that you can use to substitute with PFAS. And then, of course, the new hazard criteria for PMT, targeting also the persistent and mobile substances, which is also something that is highly relevant for the PFAS group. You have the REACH restriction proposals, firefighting foams, universal, and then a lot of other stuff. And this is also, you could say, what I will go through here, the Industrial Emission Directive. Here you have now a better possibility to address PFAS in the emissions from factories in Europe, not only PFAS and PFOA, but also involving other PFAS. You have the Industrial Emission Portal Regulation, where two PFAS have been mentioned by name, which will also give us, of course, some information on the tonnages that are being discharged from installations. The Water Framework Directive has made quite an interesting proposal. It hasn't been adopted yet, to include 24 different PFAS compounds, where you will also have mandatory monitoring of these. It's based on the toxic equivalency factor to PFOA, something that is actually being discussed quite a lot right now. So you could say the scientific foundation for this is something that is still being debated. But nevertheless, I think there is a general recognition that we need to do something on this, and also on the group and expanding, because the current status is that we only monitor for one, which is PFAS in the current version of the Water Framework Directive, and that's insufficient to actually give us an idea of what's going on in the environment. Drinking Water Directive, they already adopted a limit value of 100 nanograms per liter for the sum of 20 PFAS. Unfortunately, that was sort of developed before the latest EFSA assessment, which means that it has not been aligned with the new TDI from EFSA. And this is something that the EU Commission is looking into right now, where they have commissioned the WHO to make an evaluation of the drinking water limit for PFAS in the EU. And REACH, it has already been mentioned. We have the broad PFAS restriction proposal. It's currently under scrutiny by the eco-scientific committees. What will happen next is that they will issue their opinion. After that, it will be sent for decision making in Brussels. So the Commission will receive it, and then they will be responsible for drawing up the actual proposal that will be then put for a vote. And then we will see the final results of this work. It's a huge work and a very important one too. Then there is a restriction proposal that is more limited in scope. It's PFAS and firefighting foams, and that is already with the Commission in the decision-making process. So it's more advanced, and that will probably be decided before we have the universal PFAS restriction. We also have other groups of PFAS that has been restricted. An example is the C9 to C14, restricted since 2023. And PFHXA since will be restricted from 2026. And then there is, of course, also the candidate list under REACH, where a number of PFAS are included. That means that when you are on this list, it can then be included on the authorization list, meaning that companies can only use these substances if they are authorized in the EU in their specific uses. And then I want to mention one specific activities looking ahead, perhaps, because learning from the PFAS story, it also shows us that there are substances that has been on the market for a long time, where we suddenly realized that they were more problematic than we thought. Or on the other hand, we can also have new developed substances coming into the market, which we fail to recognize their harmful properties in time. So right now there is a legislative proposal on one substance, one assessment, where the Commission will make the EEA, so my agency, establish an early warning system for emerging chemical threats. And here you see the EEA will be responsible for collecting information from different sources, from the different agencies, maybe also from the scientific world. We'll have to see how much we can expand this. And then this will be then drawn up in an annual report, which will be sent to the Commission. The Commission will then decide on action or not on any of these substances. In many cases, they will probably need to gain more information, in which case ECHA will be responsible for the data generation to clarify the concerns that has been identified. So this is very interesting, and something that we hopefully this regulation will be adopted around Q2, Q3 this year, and then we will start implementing it. And here, of course, the interesting stuff will also be in this perspective, how we can take up relevant information from scientific research and incorporate into this, which might be difficult to do in a consistent way. It's something that we need to explore and find solutions on how to do it in practice. And then also perhaps from the EA side, we have a number of recent and forthcoming publications on PFAS. So we recently did one on PFAS in textiles and the circular economy. What happens to all the PFAS that is used in the textiles once you want to reuse those textiles for other purposes? Also, we made one on PFAS pollution in European water bodies. We made an interactive map here where you can click on your countries, then you can find actually the measurements in surface water and groundwater and see whether or not they are above or below the reference values, especially for surface water. And then we have two upcoming. One is on fluorinated polymers, which is really about the huge group of PFAS polymers. What do we know about their intrinsic properties? Should we be worried about them? And are there any recommendations on what to do with the polymers? You might know that polymers are not included in the registration obligation under REACH, which means that we don't get systematically data on which polymers that are used in the EU, and we don't get any data on their hazardous properties or on the exposure part. And then finally, we're also working on a polluter pays principle briefing, where we will use different case studies from EU countries on how they have attempted to use the polluter pays principle to make industry pay for the pollution, and also with a conclusion on whether or not this actually works in practice. So maybe to sum up here at the end, what can we learn from all this? First of all, I think the most important part is that science is the foundation for good regulation. I think this has been proven over and over again, that if you do regulation that doesn't have a solid foundation, then it always turns out to be a bad idea. So it's extremely important that the research done is being adequately taken into the processes at the right time. So that's, of course, number one. Number two, an open question: do we use too many resources on the well-known problematic substances? So in the 90s, we probably used too many resources on other compounds and too little on PFAS and PFOA. Today, maybe we use too many resources on PFAS and PFOA and too little challenges on all the other PFAS compounds. And this is, of course, because there is a tendency to work on the substances we know, and to also continue perhaps research and work that we are doing on specific compounds, because every time we clarify something, then a couple of new questions opens up, and we want to continue, we want to have the answers. But maybe we don't always need all the answers. At least I think from the regulatory and decision maker sides, you don't always need to know everything. You need to know enough to act. Because if you want to clarify everything, then you need to do a lot of work. It will take a very long time. So there is a balance in this also. We should avoid paralysis by analysis, which is something that will just drag out the process, and probably you will end up with the same result in the end. So then can we enhance the uptake of scientific studies in regulatory assessments? And here I think, yes, we can do that. I think there is a more systematic way usually of including the industry-sponsored studies than we have from the scientific studies. And they both play a vital role. And why is that? Of course, when you have the industry-sponsored studies, they are often performed via OECD guidelines and good laboratory practice. So that you can say that they have a very high degree of reliability based on that. However, on the research side, you don't often use the OECD guideline and the GLP, but on the other hand, you then use methods that are cutting edge. So they are, in many occasions, they are more relevant for what you want to know than some of the more traditional studies might be. An example, it could be thyroid disruption. If you use some of the current guideline studies, they might not tell you some of the critical issues that you want to know, but some of the studies performed by industry, they can be tweaked, they can be modified in different ways to actually give you that information. So they would have a high relevance. And here you also see that scientific studies are being validated by the peer review process, which is completely different to the regulatory review, where you use an assessment of reliability and relevance. And very often when we use studies from the scientific community, they don't contain all the details that we need to know to perform this assessment, which then makes the results difficult to use. And a lot of work has actually been done on this in recent years to enhance also the uptake, the descriptions in the material and method section to include the right information that is needed by regulators to then make an independent assessment of the methodology that has been used. So this is something that we are still improving on. And there is also in this regard the regulation that I mentioned that is on its way, one substance, one assessment, also includes some provisions to make it easier to take up and use scientific studies in the regulatory assessments. And yes, so how to enhance your uptake into to policy development and regulatory processes. First of all, I think it's very important that there is a sort of a little bit of a bias in this, because I think almost all the people working in regulatory agencies, they come from science. They have been working, they come from universities. But a lot of the researchers has never been working in the regulatory part. So there is a little bit, I mean, sometimes I feel that it can be difficult for researchers to understand what's going on, because they haven't had like first-hand experience. There's very little movability between the two, and I think it, from an academic perspective, it doesn't improve your CV very much to take a few years working for an agency, and also the other way around, perhaps publication of articles doesn't mean a lot if you want to work in an agency. It's other merits that are more important. So there is a little bit here that we are divided into two worlds, and how can we improve the communication and the understanding about what we are doing. This is really important, because then I think scientific research can also be perhaps sometimes by improving that understanding, it can be made more relevant, or perhaps there's a greater chance that it hits a mark, because it's really the detailed knowledge that's necessary. Like, it's not enough. I see a lot of applications for research projects and so on for funding, and very often it's described in a very overall way, and it's very difficult to see how exactly this will contribute to the specific problems or challenges that you have in a regulatory agency. So this is something I think can be improved. And then also, of course, timing matters. Like an understanding about the policy developments and what are the hot potatoes and so on is also something that will, of course, increase that your scientific work will be taken up. If it arrives in the right moment when there is a decision-making process going on, then that will be good. And then target the research to the substances that matters. So I think here it's important that there is a combination of hazard and exposure. You see a lot of research done on model substances that are no longer in use, haven't been used for decades to prove a concept or something like that. But it's probably not very relevant for the regulatory world. Here you want to see research on substances that are actually being used, that where we have knowledge gaps and where we want to know more about their intrinsic properties or exposure. And then I think the final here is that the work is not finalized with the publication of the scientific article. There's usually a long time from the scientific discovery then the confirmation and replication. You need to see something often in several studies, and then you have the regulatory uptake. And the same for method development. Here you develop a new method. It has to mature to prove its worth, and then you have the whole standardization process before it's been taken up. So very often you see that work is being sort of left in a limbo between these two phases, and I definitely see a gap here, or something that we can improve both from the agency side and from the regulatory side to close that gap, and to really make sure that all the resources that has been invested is being used in a good way, to actually that they transcends this sort of gap and moves into the regulatory uptakes. And then, of course, you have a lot of public consultations, and here I think it's important also that researchers make their voice heard in the public debates, and of course, remembering their role in the society. They're not meant to give policy inputs, but they can provide a lot of important scientific and technical input to these processes. The earlier you interact in a process, the bigger are the chances that something will be taken up. There was one more slide. This is just to say that from the EU agency sides, the three ENVI agencies, so the EEA, ECHA, and EFSA, has been working together to increase awareness on what are the research needs in the agencies, and we have been having a number of interactions. First of all, under PARC, where we are all involved in work package 2 on the priority setting, but we've had also a workshop on how to use scientific data in development of indicators, and that was followed up by 2 workshops on key areas of regulatory challenge, where ECHA also published a very nice paper describing a number of research needs that they have. So if you don't know these, I would recommend that you read them, because they are very detailed in describing what are the exact needs of at least ECHA in getting new important information and knowledge from researchers. That was the final slide. So thank you a lot for listening. And if you have any questions, then I would be happy to try to answer. Thank you.
No, thank you very much, Magnus. That was an excellent presentation. I thought it was a very clear representation about how the different groups interact when it comes to making chemical regulation, from the researchers, the agencies, the European Council, the Commission, the Parliament. And I think this was a very interesting example with PFAS, and how it took some time, arguably, but how the science developed and to form that policy. And if there's one thing I really like, that slide you had about how we as researchers can get involved more in policy. And I mean, just to say it shortly, it would be to be involved, to see what's going on with the regulator side. And the 0PM, this is part of the reason why we had this regulatory watch for people interested in updates with PFAS and persistent mobile toxic substances, so they can see what are the policies that are currently in the docket being discussed by ECHA, by the Commission. So if you're not aware of a regulatory watch and want to participate in the policy process with PFAS or PMT substances, check that out. We did get a lot of questions, and to those that do not know, if you have a question for Magnus, put it in the Q&A and we will try to get to it. And if we don't get to it in the last 10 minutes we have for this webinar, we'll get back to you by email, or Magnus will get back to you by email afterwards. So I'll just take these in order. So the very first question to you, Magnus, is from an anonymous attendee. Do you have or are you aware of any nature/landscape recovery initiatives where chemical monitoring, including biomonitoring or soil aquatic monitoring, is conducted to assess whether nature landscape recovery programs can be used as a method to deal with diffuse, persistent, and mobile chemical pollution? I think that's also referring to nature-based solutions, but do you know of any programs like that?
No, unfortunately not. I think what we receive at the EEA is not, I mean, it's more countrywide monitoring programs and not specific projects like that, or areas where you, but I think it's, it's I definitely think it's something that you could build in to those types of work, because it is, it is important to assess the effectivity or the efficiency of restoration. So I can definitely see the use, but unfortunately, I personally I don't know any of such data sources.
No, thank you. And now that you mentioned that, I should also plug in the great service provided by the AEA about how much data, environmental data, they're collecting from all over Europe. I'm always surprised when I find a data set that I'm looking for happens to be right there on the EEA. So in case you haven't explored what data sets the EEA has for environmental research and environmental monitoring, you should check it out. The next question.
Oh, maybe if I may add to that, there's actually this new regulation, One Substance, One Assessment, will also bring a common data platform where all the chemical related data from all the agencies will be collected on one web page. So in the future, you will find a lot of useful data. It will actually be hosted by ECHA, our colleagues in ECHA, but they will combine both what you find from industry submissions, from the analytical monitoring from the EEA, and so on. So I think that's a huge improvement also in finding and retrieving data that can also then be used for other purposes, like, for example, independent research.
Yeah, that will be extremely valuable when it comes out. So really looking forward to that and how that develops. The next question, brilliant presentation. Thanks a lot. Is there a hotspot data collection that contains data on trifluoroacetic acid, TFA, in European surface waters?
Currently, no. Because it's not included as a priority substance under the Water Framework Directive. I mentioned it was only PFAS is the only one included. But as far as I remember, in drinking water, there might be something coming in the new Drinking Water Directive. But for surface water, we don't have it yet. So what you have there is probably certain member states who have been working on this, and I know that there are member states who had initiatives, but the data is probably scattered around in different databases and systems and different languages as well. So we don't have a central European place to find that data. Mm-hmm. But it would be relevant to have that.
And I can say, at least for a start on that data set, I recently led a review of the environmental monitoring data on TFA called the Global Threat of the Irreversible Accumulation of TFA on ES&T. You can find it there, but one day it'll be on the EEA, I am sure. So next question. Many thanks, Magnus, for an excellent talk. Given we don't need to know everything, what are our priorities for further research and environmental surveillance?
Okay, I mean, that's a quite broad question, and I don't think I can answer that. But I just wanted to, the reason why I picked this up is that you very often see, as I mentioned, research on substances that has already been restricted or banned. And of course, that can be interesting for different purposes. You can still, lower limit values. You still have exposure to many of these sins of the past. But in a forward-looking perspective, the regulators are very interested in knowing what are the substances that we are currently exposed to and that are currently being used in products. That's where you can act. That's where you can do something and remove the exposure. The other stuff, often you don't have the possibility, like PFAS. We know it's there. We know we're exposed. Lead, the same. Mercury, it's very limited what you can do about it. Whereas the other substances that are still in use, here you have the possibility to address that before we have more pollution. So you could say they have a higher relevance very often in sort of the regulatory view, and this is where we often also lack a lot of data, because people tend to focus on the same substances that they have been working with for a long time, and it takes some time before you pick something up, you identify a problem, and then you see research explodes and you see a lot of articles coming out. But it typically also takes a period of, up to 5 years or even more before you see that development. So I just try to push for a little more thoughts about, should we also look more broadly into the chemicals that we are doing our research in.
Mm-hmm. And I should have mentioned that question was from John Redshaw, and your answer also leads up to his next question. what are the biggest bottlenecks to progress, and how are these being addressed?
I assume here it's a bottlenecks for the regulatory uptake of the scientific research then.
Yeah, to be faster, I think, yeah.
Yeah. I mean, we are progressing quite a lot. I think what we have seen is in the last 5 years, there has been a change that there now is a general recognition. There was a strategy for the Commission to ban a lot of uses, and we have a restriction proposal which is in the process. So I don't think actually there is a big sort of gap on that now. We have already, I think, acknowledged the problem. And then we'll have to see, of course, how it ends. Again, the process is now in the scientific sort of assessment part in ECHA. Then there will be the policy part with the Commission, where they, of course, will look into all these other aspects, not only the environmental or human health aspects, but also the broader dimensions of what a ban means and where you need to have exemptions, because there are certain critical uses that we want to have in our society. So, I mean, this is something that will a process that will continue in a couple of years from now, at least.
Mm-hmm. No, thanks. And the next two questions, it was another one from John Renshaw, but also an anonymous attendee. It's about the international sphere. So I'll read this question. Can we expect an international policy instrument on the PFAS? Is it worth highlighting the difference in the impact on environmental policies, like from the UN level, from this upcoming international panel on waste and chemicals and pollution, and also the Stockholm Convention? What can we do to globalize what Europe is doing?
I mean, that's a more difficult question, because there are different regulatory frameworks around the world, and we have different views on how to approach this. I mean, the European part has a higher sort of focus also on the intrinsic properties and using that to regulate chemicals. So talking about PBT or very persistent, very mobile substances, whereas, for example, in other regions, they focus more on the risk. And if you have a risk-based approach, then you need to know the exposure to each of the different chemicals in order to decide on an action. So this is where I see that there could be some differences. Of course, you have the POPs, which is also intrinsic properties, and that could be a way forward, but it's very difficult to foresee what will happen in the international arena. We know that certain PFAS is already on the Stockholm Convention, but whether or not PFAS as a group, I'm a bit more skeptical about that. But again, we'll have to see what happens after. I think the first step now is to have the restriction on a European level.
Mm-hmm. Mm-hmm. Yes, but again, to say from my side, I do think that this is an issue that is taken up by the International Panel for Chemicals, Pollution and Waste once it is established from the UN. Okay, this is a trickier question. We got 1 minute left, but we'll take this one as the last one. I'll just respond to one person who asked about slides. These slides will be shared, and there'll be a YouTube presentation recording of this, so that will be available. I'll end with like one. Oh, and I see that we are out of time.
Saved by the bell.
And we try to be on time with these webinars, but some very interesting questions to be asked next, but we will take those by email to the people that
sorry, Hans-Peter, I will just interject that those people who have posted a question, a lot of them have come from anonymous attendees, so it's going to be impossible for us to actually follow up. So if you did have a question and you wanted to reach Magnus, if you send it to me first, I will forward it on to Magnus. We can say like that. If you wanted to post those anonymous questions first to me, I'll send them to Magnus.
Yes,
okay.
That'd be great. Thanks, Sarah, for bringing that up. Yeah,
that's
very
okay.
good. Okay, but with that, everyone, Magnus, I want to say thank you so much for this very clear and excellent presentation. I learned a lot. I got clarity on a lot of issues. So thank you very much. And please, everyone, thank you for attending this 0 PM webinar. Make sure to check out 0pm.eu and our LinkedIn page for more updates and further webinars from our project. For me and for Sarah Hale, thank you very much.
0 PM. Zero pollution of persistent and mobile substances.
This project has received funding from the European Union's Horizon 2020 Research and Innovation Programme under grant agreement number 101036756.